This is number 15 from the worksheet on Thursday. It says find all the rational zeros. So to do that, we list our p's, which are all the factors of 54, right? 1 and 54, 2 and 27, 3 and 18, 6 and 9. Okay, this is 2 nights ago, Thursday nights. And then it's plus or minus on all that, and my q is 1 and 2. The factors of my leading coefficient. So my p over q, okay, and we'll talk a little bit, let me just also talk a little bit about tonight's worksheet. The first two problems are, it's a multiple choice or multiple answer, and it says, what zeros are not possible in this list, if you look at today's worksheet. So you make this list and you see which ones are not on there, right? So if 6 was on there, is 6 a possible zero? On this answer? Yeah, 6 is possible, right? Is 7 a possible zero? No. So any of the answers that had 7 in it wouldn't be possible because it's not on our list, right? And then the second question on tonight says which ones are possible. So you're finding the ones that are on your list. Marissa?
So for the first one, we can just circle all the ones that are possible. We have to solve them.
No, correct. The first one's not possible. And the second one is possible. You don't have to solve for any of them. You're just selecting the ones that are possible or not possible, whatever. So plus or minus 1, plus or minus 2, 3, not 5, 4, 6, 9, 18, 27, and 54. And then over 2 means I can put the odd ones over 2, right? Plus or minus 1/2, 3 halves, 9 halves, 27 halves. I don't need to put the even ones on top of the 2 because those simplify to numbers that are already listed, right? And then we start checking. Now, we want to check in order, right? Because what did I tell you about the way we set up our tests? We set them up so if you do 1 and -1, 2 and -2, you're going to find one pretty quickly. We don't want to send you all the way to 6, so you have to check 17 numbers before you find one that works, right? So we make sure that the problems have a 0 in the first 4 numbers, 4 to 6 numbers, okay? So that's why you don't want to go all positive and then check all the negatives, because that would give you, like, what if the answer was -1 and you checked all the positives first, right? So we're going to check +1. And we check using synthetic division to -7, -21, and 54. Bring down my 2, 5, -16, 20, -5, -26, -26, not 0. -1, 2, -2, -9, 9, -12, 12, not 0. 2, -7, -21, 54, 2, 4, -3, -6, -27, -54, 0. No, because this is our last resort. The rational root theorem, there's no quicker way because it's what we do when we can't factor it. We can't factor by grouping. There's no other way to find your zeros because it's not factorable. We have to use the rational root theorem to get us to the point where we can then factor or use quadratic formula. There's no other way other than graphing it and finding the zeros on the graph. Right, but those are always just approximations, especially with the decimals. Yeah, so this is like your last resort if you don't know how to solve an equation. So we found an answer. Now we have 2x squared minus 3x minus 27. And is this factorable? 2x and x. What in the heck? Leave messages. 9 and 3, 6x and 9x. Negative 3 would make it negative 9 and positive 3. All right, so then it's 2x minus 9 equals 0, and x plus 3 equals 0. So we add 9, 2x equals 9, and x is 9 halves, and minus 3, x is negative 3. So there's my 3 answers for the x to the third power. Okay. The 2. Yeah. So x is 2, 9 halves, and negative 3. Okay, number 19. That's the answer. These are my answers. 2x to the fourth minus 7x cubed plus 4x squared plus 7x minus 6. So luckily this is a small list. 1, 2, 3, and 6. 1 and 2. I don't know. Technically, my daughter had surgery when she had the tooth removed, and so they're calling to follow up on her. Her name is not Bailey, but that's just Siri. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, and then plus or minus 1 half, and plus or minus 3 halves. Right? Those are my possibilities, right? All the combinations. So if I said, is 4/3 a possibility? No. Would 3/4 be a possibility? No. Would 5 be possible? No. Okay. Only ones that are even remotely close to working are the ones on this list. Okay. So, check 1. It works. This is what I really wanted to talk about. I found one that worked on the first try. I do not go back to the original and keep going. I start with my new polynomial. Remember that this is 2x cubed minus 5x squared minus x plus 6. It has the same constant and leading coefficient, so the list is the same. I know that I already got one to work, so I'm going to try the next one. Now, that doesn't mean there's not double roots, like sometimes there are, but we don't go and check them several times, because that would, I don't know how effective that would be. So now we're going to check -1 with 2, -5, -1, and 6. This is how we go from 4th degree to 3rd degree to 2nd degree. 2nd degree, we can either factor or use quadratic formula. So that's how we can always make sure to solve, right? And this is like our last resort. We can't figure out any other way to get a solution, so we have to use this. So 2, -2, -7, 7, 6, -6, and 0. Yes, we got another one. So far x is 1 and -1. Now I have 2x squared minus 7x plus 6 equals 0. And let's see if this factors. 3 and 2. That doesn't work. 3 and 2. 4 and 3. There we go. That's ugly. 3 and 2. That's 4x and 3x, negative and negative, right? The negative gives me a positive 6. So that's 2x minus 3 equals 0. X equals 3 halves. If you add 3, divide by 2. And x minus 2 equals 0. X is 2. So I have -1 and 1, 3 halves, and 2. Those are my 4 answers.